So if you see here, the second option here, it is a square minus b square is equal to a plus b into a minus b, right? So if I somehow try to expand this way, like a multiply a and a multiply b, and also b multiply a and b multiply b, I'll get this one. So a square, I have to take all of them into left side. I have to take them on the left side. Okay, so a square here and b square here, it was our previous equation, and then we okay, so, no, we don't need to take them on the left side, just the multiplication. Okay, so a multiply a is a square, a multiply b is plus ab, and b multiply a is minus ba, and then minus b multiply b is minus b square. So you can just see, like, we cannot cancel out. So we have on the left side we have a square minus b square, but on the right side we have a square minus b square, and also we have extra part, that is minus ba plus ab. So we cannot cancel them out because these are not some kind of this is not like 2 multiply 3 plus 3 multiply 2. Okay, this was some kind of algebra, like 3 multiply 2 is 6, so we have minus here, so minus 6. Oh, sorry. So it was minus 6 plus 6. Okay, so it can be cancelled, but these are not some kind of numbers, they are vectors. So for vectors we cannot write down ab is equal to b. Okay, because it changes the direction. Guys, can you understand? For vectors we cannot write down ab equal to b because it changes the direction. So that's why we cannot cancel out this ab and b. Okay, so they are not similar. So we can just say, like, this second option is not true. Although this is a formula, this is a algebraic formula, a most common algebraic formula, but you know, for vectors we cannot write down this way. Okay, guys.
Yeah, bro.
So for C we have b plus c multiply k and k. So if you just multiply this constant with b and c, it is okay. Okay, for vectors you can multiply any constant with 2 vectors, so they will remain the same. So the correct answer is C. And for D, we have a multiply b transpose. So a multiply b transpose is not equal to their separate transpose. Okay, so this goes against the formula. So the correct answer is C. I have written here. Okay, so ab transpose is not equal to a transpose into b transpose. So if it was like b transpose into a transpose, that was correct. But from the formula, we can say that this is not correct. So I think you can understand the third question, right? Mitchell is not here. Imposo is here, right? I can't expel the Chinese character. So let's continue the fourth question here. Hassan, can you understand? Farha, can you?
Okay.
Hi, Koi, right?
I'm confused.
Koi.
I'm a bit confused.
Which part you are confused? Which part?
I know the C is correct, but I'm confused with the D.
Okay, so from the formula. Okay, from the formula.
Yeah, assume that ABC are
Yeah.
the 1 by 1 matrix.
AB
Okay,
transpose
scalar.
from the formula transpose of AB matrix, it is B transpose into A transpose. Okay, this one is correct, but
Okay, so it is the opposite form, maybe.
from the formula this is not correct.
Hmm.
So that's why this is not our answer. Okay, so if we look at number
Okay,
4, so number 4 here. If a matrix A n by n is invertible, then the following statement is hold. So invertible means, okay, number 4. B is the correct answer. So if it is invertible, then x is equal 0 have infinite many solution. So this is not true. Okay, so I don't know why this is not true. I don't know the explanation because Laushi didn't give any explanation. So you just assume that if A is a n by n matrix, if it is invertible, then Ax is equal to 0 have infinite many solutions. This statement is false. And then number B, the reduced row echelon form of A is I to the identity matrix of n order. Yeah, that is true. I mean, if you just try, okay, so let me write down some matrix. If we have on 2 minus 1, so 2 3 1, and then maybe, okay, I'm just writing some random numbers. Okay, 5 2 3. So if you find the REF form, I mean the reduced row echelon form, and then if the reduced row echelon form, okay, so you can see this is a square matrix, right? It is a 3 by 3 square matrix. So the reduced row echelon form is of A is an identity matrix because it is invertible, right? So if it is invertible, I mean invertible means what? So this matrix is not invertible, so I have to write down this way. On to it will be minus 1. Okay. If this is minus 1, then it is invertible. Okay. Like if you just make the column as row, okay, just make this column as a row, so it will be 1 2 and minus 1. So this way 2 3, okay, so 2 3 it will be not 1, it will be 2. Okay, if this is invertible, then it will be 2. So then you just invert this row, it will be 2 3 2, and then the last row it will be minus 1 2 and then 3. So if you invert the last row, it will be also minus 1 2 and 3. So you see that these two matrices, they are same, right? I found I calculated the inverse. I make the row as column. So I make the row as a column, and then I get the same matrix, right? The same matrix, the same entry all around, and they are 3 by 3 matrix. So we can say that the reduced row echelon form is an identity matrix. So if we calculate the RDF, we will get a 3 by 3 identity matrix. That means 1 0 0, and then 0 1 0, and then 0 0 1. Okay. So this is what this question is saying. Okay. And number, guys, can you understand this part? I think Mitchell, he have some problem with the internet connection.
Yeah, bro.
Yeah. Okay. So. Okay. Number C. A is not expressible as a product of elementary matrix. This matrix is not expressible as a product of elementary matrix. So elementary matrix means if we have a matrix and for example on 2 and 2 1, okay. Oh, I have to write down it a little bit bigger. 1 2 and 2 1. So elementary matrix means if we somehow can convert this matrix to RREF with only on row operation. So what can I do? I can just multiply the first row with 2, and then I can subtract the first row from the second row. Okay, that means 2 into R1 minus R2. Okay, so I will get what? I will get. So we are changing. We are making change to the second row. Okay, so 2 multiply 1, it will be 2, and then 2 minus 2, it will be 0, right? So I keep the first. So I keep the first entries, and then I change the second one. So it will be 0, right? Okay, fine. And here it is 1, and then I do another row operation, and that is I multiply 2 with the second row, and then I multiply the second row from the first row. So it will be, so I make change to the first, I make change to the first row, and I multiply. Oh, this will be like R1, right? So I multiply the first. I make change in the first row, and I multiply 2 with the second row, and I subtract the second row from the. I subtract the first row from the second row. So if you multiply 2 here, so you'll get 2 multiply 1, that is 2, and then 2 minus 2, that is 0. So you will get 0 here. Okay. And then, okay, so 2 multiplied 2 is 4, 4 minus 1 is minus 3. Okay, so maybe not this one, can we? This is making some error here. So if you look here, 2 multiplied 2 is 4, and then 4 minus 1, that is minus 3. So there is some problem. No, not this row operation. Okay, maybe we can do something else. The first one is okay, but for the second row operation, maybe we need to make some change. So I just took this number as random. So if we somehow can convert this matrix into a identity matrix with only on row operation, then that is called elementary matrix. Okay. So let me search on Google so that I can find any 2 by 2 elementary matrix. So 2 by 2 elementary matrix. R1, R1 minus R2. So you can see a elementary matrix here. So it is 3, 3, 0, and 0 minus 1. So if you do a row operation, like if you just divide the first row with 3, I mean if you just do this row operation, R1 is equal 1 by 3 R1, 1 by 3 R1. So you just divide the first row with 3. So 3 by 3, it will be 1. and 0 by 3 it will be 0. So you will get like 1 0 and then 0 1. Okay, so you will get a 2 by 2 identity matrix. So you see, doing just on row operation, you can get some identity matrix directly. So this is called elementary matrix. Okay, so there is some more example of elementary matrix. Here is one. Okay, so I think you can understand what is elementary matrix. If we do just on row operation and we can end up with an identity matrix, so that is called elementary matrix. uh, Guys, can you understand? Okay, so let's continue.
Too great, too great.
So where we left? So now the fifth question. Oh, don't worry. We all will do better in our exams. We just need to review the test paper. I think it will be the question will be very similar to this test paper. So now the fifth question here, it is if if this matrix is equal 5, then which of the following inequalities is not true? So the first option here, CBA FEDIHG. So we just CBA. So they just make some inverse. Okay, so the row was this way, ABC, and they write down this way, CBA. Okay, they write down the opposite way. So it was DEF, so they write down FED. So this way. Okay, and if this is -5 or not. So from the formula, okay. CFI, ADG, CFI. Okay, so not that way. Okay, let me explain again. So here they are just flipping the column. Okay, so they are just flipping the column. So this column was here, and this column was here. So if we flip the column, or if we just exchange the column, so we will get a minus sign here. Okay, we will have to write down a minus sign here. So the initial value was 5, and then when we exchange the column, so we will get a minus sign here. So this one is correct. And then the next one, it is A minus D, B minus E, and C minus E. A minus D, A minus D, B minus E, C minus E. So if you have a closer look here, so they have done a row operation, that is row 1 minus row 2. Okay, row 1 minus row 2, like this way. What is the, okay, A minus D, okay, row 1 minus row 2, B minus C, and then C minus F. So they have done this row operation. You can see here, And okay, so here is a minus, right? So on the second row there is a minus. So you see here they have multiplied with a minus sign. So you can take out this minus. You can take out this minus outside of the matrix. So now you are left with this one. And then okay. Then if you do this row operation, so the value is not going to be same as minus 5. Okay? Because we already have seen here. Uh, if this is minus 5, and if you do some row operation this way, like c minus f, then d minus c, so we have changed the first row, right? So if we change the first row, so we cannot get minus 5 here. So this is not true. Number c. Okay, number c and d. So number c, we have minus 3a, minus 3b, minus 3c, so def, and g minus 2d, h minus 3, I minus 2f equal 30. So if I take just minus 3 out from the first row, then I will get this one. And we already know that this part is equal to 5, right? This part is equal to 5. If you look at here, this part is equal to 5, right? From the initial from the given value, this part equals 5. So we have just taken minus 3 out, and then we write down here 5. So minus 3 multiply 5, that is minus 15. But here it is written as 30. So this is not also true. And then, but I'm not sure about the third row, because they have also changed this row. Z minus 2D. So if I multiply 2 here, so that will be okay. As Laushi didn't give any explanation, so I'm not sure how about the third row. Okay, but we can just get it was minus 15, so this part is not true. And then the fourth one, D here, so we can take out minus sign here, so we take minus here, so all of them becomes plus. Okay, we just take minus sign out of the matrix, and also we take this 2 out of the matrix, so we get here another 2. So minus 2 multiply 5, that is going to be minus 10. So why that is not true? Minus 2 multiply 5 is minus 10. Okay, minus 1 into R2, 2 into R3, 2 into R3, yeah, minus 1 into R2. Okay, so D also is true, but why, I don't know why they didn't give D as false. Why they have given D as false? Let me see that answer of our last year. So if you look here, the change, like I had a mistake. So it was GSI, right? In the last row was GSI, but on the first option A here, it was ISG. So that's why this is not correct. So I told you this is correct, but this is not correct. Okay, my mistake, because you see here we have GSI, but here we have given ISG. So we can say that this statement is not correct. I thought it was GSI. Okay. Anyways, so only the third statement is true, but I don't think. I think fourth statement 15 and then okay. So multiply 2. It is really complex thing. I mean, GSI, then D multiply 2. Okay, so if you look here, I'm going to explain from here, not from my notes, because there is some mistake here. So if you just take this minus 3 out of this matrix, so you will get here a minus 3. And then if you see here, we have row operation, that is 2D and 2E and 2F. That means they have multiplied 2 with the second row, right? So we can now take out this 2 also. So, okay, fine. So we get minus 3 multiply 2, that is minus 6. And then the initial value, I mean A, B, C, D, E, F, and GSI, the initial value was 5. You can see here, the initial value was 5. So if I multiply 5 with minus 6, it will become minus 30, right? And then it is plus 30. So then the absolute value, okay, so the absolute value of what is the matrix? G minus 2D. G minus 2D. Yes, I'm not pretty sure about this answer, so let's just skip this one. Yeah. So Zakira and Zama and Farha, they have the same kind of name, right? So you are making fun of it. Okay. So let's continue to the third part. Who is still here? Okay, 4 of you. Calculation problem. So, oh, we have already discussed only 30% of marks. We still have 70% marks remaining. So I think we need another group study tomorrow, right? Because there's a
Yes,
lot.
bro.
There's a lot to cover.
There are plenty of homework remaining.
Yes, right. So if I was so talented like a Laosi or something like, so I could explain much faster. But I just need to look at the answers and think of the previous lectures.
Omar,
So that's why I was a little bit slow in explaining. So I'm sorry for that. Okay.
Omar,
Yeah.
did Laoshi discuss about the calculation problem?